We are going to start a new topic, that is dative covalent or coordinate covalent bond. This bonding is also a type of covalent bond. In a covalent bond, electron pair is shared between two bonded atoms. But in this, when two or more than two atoms are making a bond, then one of the bonded atom donates one complete bond pair, not a single electron, share complete bond pair of electrons. This type of bonding is called as coordinate covalent bond or dative covalent bond. The atom which donates the electron pair is called donor, and the atom which accepts the electron pair is called acceptor. For example, if there are two atoms, one atom is donating the pair of electron, not a single electron, the pair of electron, then this atom is called as donor, and the atom which lets the electron accept this pair of electron is called as acceptor, and the pair of electron on a donor atom is called as lone pair. This donation of electron pair is represented as arrowhead. Tail of the arrow towards the donor and the head of the arrow towards the acceptor. Here you can better understand the dative covalent bond. This is the ammonia molecule. Ammonia molecule having 3 hydrogens and 1 nitrogen. Nitrogen having 5 electrons in its outermost shell and hydrogen having 1 electron. Nitrogen share its 3 electron with the 3 hydrogen atoms by making 3 single covalent bonds. One lone pair of electron is available on this nitrogen. So this nitrogen behave as a donor. Here you can see the proton, the H positive ion, it lacks electron, having no electron. As we know, hydrogen having 1 electron, but this positive charge represents that the hydrogen having no electron. The 1 electron is lost by this hydrogen. So this is now a proton. So this lone pair of nitrogen will be donated by the ammonia molecule, which is represented by arrowhead. Tail towards the lone pair and head towards the acceptor. This is acceptor. And this is a lone pair of electron. So in this way, this molecule of ammonia and this proton will come closer and make a bonding. You can represent the coordinate covalent bond by making the bracket and positive charge on the bracket. Now this new species is called as ammonium ion, because this is called as ion because this contains a charge on it, and the coordinate bond is represented as a arrow, tail towards the donor atom and head towards the acceptor atom. So this is the coordinate covalent bond between ammonia and proton to make ammonium ion. Here you can see another example. Ammonia, as we know, having a lone pair of electron. Here you can see boron trifluoride. Boron trifluoride. Boron having atomic number 5. First shell having 2 electrons and the second shell having 3 electrons. That's why this boron atom make 3 bonds with the fluorine. Fluorine having 7 electrons, lack of 1 electron. So in this way, this boron make 3 covalent bonds with 3 fluoride with 3 fluorine atoms to make a covalent bond boron trifluoride compound will form. Here you can see boron lay 2 electron. 1, 2, 3, 4, 5, 6. Boron having 6 electrons in its outermost shell. This boron needs 2 electrons to complete its octet to contain 8 electrons in its outermost shell. So this ammonia will donate its lone pair to this boron atom. By this donation of lone pair from this donor ammonia to this acceptor boron trifluoride, coordinate covalent bond will be formed. This arrow represents coordinate covalent bond. This coordinate covalent bond will be formed between ammonia and boron trifluoride. This bond is also called as dative covalent bond. If the molecule with the lone pair approach the molecule having lack of electron or do not having 8 electrons in its outermost shell, do not following the octet or duplet rule, then that molecule quickly take the lone pair from the donor and make a coordinate covalent bonding with that molecule. Next, we having a topic about polar and a non-polar covalent bond. If the two bonded molecules, for example, these two bonded molecules, if the two bonded molecules are similar means homoatom, homo means same, homoatoms, similar atoms, for example, Cl, both are same atom, they are homo molecule. In this homo molecule, the shared pair of electron is equally distributed between these two atoms. Due to that equal distribution between these two atoms, both the atoms will not carry any charge. That's why they are called as non-polar, having no poles, because there is no unequal distribution of electrons. But if there are unequal distribution between two bonded atoms, for example, heteroatoms, hetero means different. For example, HCl, both are different atoms, one is hydrogen and one is chlorine. If the covalent bonding between two heteroatoms, then due to the difference of their electronegativity, due to the unequal distribution of electron between these two bonded atoms, due to the difference of electronegativity between these two atoms, electrons are unequally distributed because of the difference of electronegativity. So unequal distribution of electron between these two bonded atoms. Due to the unequal distribution of electron between these two atoms, they carry partial positive or partial negative charge. Hydrogen having electronegativity 2.2 and the chlorine having electronegative value 3.2. So the difference is 1.0. Both having the 1.0 electronegative difference. Due to this difference, they contain partial positive and a partial negative charge. As we know, hydrogen is less electronegative as compared to chlorine. So due to the more electronegative value of chlorine contains partial negative charge, because chlorine will attract electron pair more towards itself as compared to hydrogen. Because hydrogen having less electronegativity, it will attract lone pair of electron towards itself less than chlorine. As we know the definition of electronegativity, the ability of an atom to attract the shared pair of electrons. So chlorine having more ability because more electronegativity to attract the shared pair of electron towards itself. So due to the difference of electronegativity, they contain partial positive and a partial negative charge. Partial sign is represented as delta, this sign of delta. So due to partial positive and a partial negative charge, this is called as polar covalent bond. Here you can see in an ionic bond, there is no partial charges, there are complete positive and a negative charges. Because there is no sharing of electron, there are complete transfer of electron. So that's why they are ionic bonds. But in a polar covalent bond, partial positive and a partial negative charge form, there is no complete transfer of electron, just sharing of electron, and one bonded atom attracts more electron towards itself for a more time being as compared to the other atom. Here you can see the non-polar covalent bond of fluorine molecule. One fluorine atom and another fluorine atom. They both having the same electronegativity. So that's why they do not contain any partial positive and a partial negative charge. That's why they form a non-polar covalent bond. But instead of it, if there is hydrogen fluoride covalent molecule, then both having the difference of electronegativity. Hydrogen having electronegativity 2.2 and the fluorine having electronegative value 4.0. So you can observe that there is a difference of electronegativity between hydrogen fluoride. Due to that electronegative difference, electron pair is more attractive towards the fluorine atom as compared to the hydrogen atom. So due to that difference of electronegativity, hydrogen contains partial positive charge, and fluorine contains partial negative charge. It will make polar covalent bond, polar covalent molecule. Here you can see some examples of polar and non-polar molecules. When the bond between oxygen and hydrogen, then the molecule will be polar because there is a electronegativity difference. So here you can see the molecule of water, one atom of oxygen and two atoms of hydrogen are making a molecule of water. There is a difference between oxygen and the nitrogen, oxygen and hydrogen's electronegativity. Due to that difference, it will make polar molecule. If the bond is between carbon and hydrogen, then there is not a very much difference of electronegativity. Due to that, they will make a non-polar molecule. In a polar molecule of carbon and oxygen, here you can see the bond is polar. But if that molecule is linear, then that molecule is considered as non-polar. Here you can see the molecule is linear. Due to that linear, their dipole value is 0. That's why it is considered as non-polar molecule. Here you can see some other examples of polar and non-polar molecule. There is electronegativity difference between hydrogen and chlorine. Due to that, partial positive and a partial negative charge obtained and makes a polar molecule. In a water molecule, partial positive charge on both hydrogens and partial negative charge on oxygen is formed due to the difference of electronegativity. That's why it is a polar molecule. In ammonia, there is also a partial positive and a partial negative charges between the bonded atom due to the difference of electronegativity. That's why they make a polar molecule. Here you can see the homoatomic molecule. Both are nitrogen. Due to the homo atoms, there is no difference of electronegativity, so no charges are formed. Due to that, this is a non-polar molecule. Here you can see there is a difference of electronegativity, but the molecule is linear. Both the oxygen atom will apply the same force to attract the electron pair towards themselves. That's why the bond is non-polar covalent bond, because of this linear, because of this equal attraction for lone pair of electron, no charges will form. Here you can see also the attraction towards the electron pair is equal from four sides. That's why this molecule will not carry charges. That's why it is also a non-polar molecule. The very important thing about this topic is that if the electronegativity difference is more than 1.7, the bond is ionic. By the difference of electronegativity, you can identify the compound is ionic or the compound is covalent. If the difference of electronegativity is 1.7, then the compound is ionic. But if the difference of electronegativity is less than 1.7, then the bond is covalent. Remember, if the difference of electronegativity between the bonded atom is more than 1.7, then the bond which is going to be formed is ionic bond, and if the difference of electronegativity is less than 1.7, then the bond is covalent bond.